All right, and let's do another one of those in letter D. But to do that, we're actually going to move over here. And for letter D, we're going to just note right away what the prime factorization is. Okay, so 5 is already a prime factor. This is going to be 5 times P times Q times Q times Q times Q times Q times R. Here I've laid out the term in all of its factored glory. All right. 10 is going to be 2 times 5, because 10 factors really simply to 2 times 5, and those are the prime factors that make it up, times P times Q times R. Notice here I did something a little different. I just made columns of factors that I knew were the same. So I put the prime factorization of 10p q squared r squared down here, but I just lined up right away my p's with my and then my q's and then my r's. All right, and that makes it really easy to do something like this, where we circle the factors that we have in common here. Let's see if this is the right one. There we go. All right, there is our prime factorization of each term. And now I can see that we have 5p q squared r squared in common. And then I have some other letters and numbers that are not included. Those I'm not worried about right now. I'm just going to note that when I multiply the circled things back together, I get the greatest common factor. This is the number that will divide both of these terms evenly without any remainder. All right, on to letter E. Letter E, I'm just going to show you right away how it's done. So in letter E, we have 8d squared e squared. I've already prime factorized it. 8 is just 2 times 2 times 2. If you ever see 8, you can recognize that that factors down to 2 cubed, 2 times 2 times 2. 12 we already did, I think, or maybe not. Well, we kind of did it as we were doing 24. So 12 is 2 times 2 times 3. And then I list my D's and my E's. Here's my D's, here's my E's, here's my D's, here's my E's. So I list these, and then I'm going to circle the ones that are alike on the top and the bottom. I end up with 2 squared, D squared, E squared. Okay, now notice I'm going to put my 2 squared, which is 4, D squared, and E squared right here. But this asks me to go one step further. It tells me to factor the polynomial, not just write the greatest common factor. So here, what I need to do is say, okay, what do I have, if I'm going to undistribute this greatest common factor from these two terms, what is that going to look like? And then if I redistribute this back into those terms, I would actually get what we originally had. What I do is I write what's in circles first, okay, and then an open parenthesis, and because this is a binomial, I'm going to have 2 terms in my parenthesis. Notice that my first term, 2e, is just what was left over after I eliminate all the circled terms. So I have a 2 and I have an e that aren't circled. I'm going to put that first. I need a sign for the middle. In this case, it's the plus sign, because there's a plus sign in this problem. And then in my second term, I use what I didn't circle down here, 3d. So it's going to be 4d squared e squared times 2e plus 3d. And what you'll notice is if you redistribute this 4d squared e squared back in, what do I get? 8d squared e cubed. Why, that's this term. Plus, here's the sign in the middle, and then 12d cubed e squared. Okay? So what you're doing when you factor polynomials is you're undistributing something. In this case, we are undistributing the greatest common factor. Let's look at letter F and see if we can do the same sort of thing for letter F. So in letter F, I have 12x to the 4th y squared z. That breaks down to, again, it's 12, so 12 is 2 times 2 times 3. X to the 4th is x times x times x times x times y times z. Now I notice I have a minus here. I'm going to keep that information tucked away for later. Then I need to break down 42. 42 is going to be 2 times 20. Let's see, 2 times, let's see, is it 2 times 21? And then 21 is going to break down to 3 times 7. So it's just going to be 2 times 3 times 7. Now, I could have done that with a factor tree, or if you're really good at this, you could do that in your head, or however you want to do it, but you do need to get a prime factorization for each of your constants. Then x times x times x, y times y times y, z times z. And I've got it all laid out here. Now I'm going to circle things that are in common between the top and the bottom. Notice this one I didn't line up my like terms. It might have helped to do that. It might have made it a little easier. But you could also do it this way where you just circle things diagonally that are in common with each other. Okay, so 2 times 3 are the numbers that they have in common. X times x is in common, y times y, and 1z. So when I put this all together, I'm going to end up with 6x cubed y squared z. I'm going to note that that's going to be what's outside of my parentheses in my factorization, when I factor the number. Okay? Now, what's left over on the top? On the top, I have a 2x left over. I'm going to put that in parentheses as my first term. Now I need to decide whether I'm going to copy down a plus or a minus. Back in my original expression, I notice I have a minus in between. So I'm going to copy down that minus here in my expression. And then I'm going to copy down whatever I didn't use from the second term, 7y, z. That z looks a little hard to find. You have to make sure you can find everything that's not circled. 7y, z is my last term. This is the factored polynomial, okay? How do I know it's completely factored? Because I factored out the greatest common factor between the two terms. And I can double check this if I just think about multiplying these back together. If I multiply these and redistribute this, I get 6x to the fourth y squared z. I'm sorry, 12 because it's 6 times 2. 12x to the fourth y squared z minus 42x to the third y cubed z squared. So see how this works? Pretty handy. Let's do letter G. We're just going to do this in one swoop. Now, here's the thing about G. Actually, I'm going to do this sort of in pieces. G has a fraction bar in it. Okay? So it's all divided by 6 at the end. And when I have a fraction bar in something like this, what I need to do is just worry about what's above the fraction bar first. And then we'll worry about the 6 at the very end. So above the fraction bar, I have a binomial, 2 terms. Let's factor that binomial. 6x squared, 6x plus 18 becomes 2 times 3, just the 6x term, 2 times 3 times x. 18 becomes 2 times 3 times 3. Okay, so if I made a factor tree for 18, you'd see it's 2 times 3 times 3. And then I'm going to go ahead and put those. So the thing I have in common is 6, right? The thing I didn't use for my first term is an x. The thing I didn't use for my second term is a 3, and I have a plus between them, so it's going to be plus 3. I have to remember that this factored binomial, though, is being divided by 6. Hey, what's 6 times x plus 3 divided by 6? Why, that original factor is going to cancel out in the top and the bottom, and I'm just going to be left with x plus 3. The 6 cancel. Let's see what happens with h. Same sort of thing in h. I'm going to start with my prime factorization for 18x and 45x cubed. Those are the things that are on top of my fraction, so I'm going to ignore the bottom of my fraction for right now. I'm just going to note that I have a bottom of my fraction by putting it right here, and I have this wrong. The bottom of the fraction is going to be 9x on this side. Okay. All right. So I'm just going to note 18x factors down to 2 times 3 times 3x. 45x cubed is 3 times 3 times 5 times x times x times x. What do I have in common? 3x. Those multiply out to 9x. So that means that I'm going to have a 9x out in front of my parentheses. And then what do I have left over on top? Just a 2 for my first term, a plus in between, and then on the bottom I have 5x squared, okay? 5x squared. And now the 9x out front is going to cancel with the 9x on the bottom of the fraction. So I'm going to be left with just 2 plus 5x squared. That's how these types of problems work out. And then the last one, I'm not a huge fan of this problem. It ends up being sort of a trivial problem in the end, but let's take a look at it. Okay, so letter I says that we have a formula, and we're going to try to rewrite the formula factoring the right side of the equation. So all we need to do is factor the right side of the equation. It's sort of hard to figure out what they're asking for. One of the things they say that we need to do is make sure that the t squared term is positive. I'm going to show you how to do that in this. It's kind of tough to do, but part of what we're doing is we're dealing with a trinomial now, not just a binomial. We have 3 terms, and we need to find the greatest common factor of all 3. So what are we going to start with? Well, let's start by finding the prime factorization of each of our terms here. And let me just make sure I get the whole thing in. So let's see, 16t squared. I'm going to ignore the negative out front for right now. 16t squared is 2 times 2 times 2 times 2 times t times t. 60t is 2 times 2 times 3 times 5 times t. And if you want to check me, I did it this way using factor trees, but if you just multiply everything back together, you should be able to get 60 from this. You should be able to get 16 from this. And then we also have 4 as a number. So I have 3 numbers that I have to find the prime factorization of 2 times 2. Now, the 2's are the only thing that all 3 terms have in common. I'm only allowed to circle things that all 3 terms have in common. So what can I factor out of all 3 terms? The only thing I can factor out is a 4. Now you'll see I made it a negative 4. Why is that? Because I need my first term, this 16t squared, to become positive. How do I make a negative term positive? Well, if I factor out a negative, it changes that back to a negative when I multiply it back in later. So that means that if I factor out a negative, I'm going to have to make sure that in parentheses this term is positive, so when I multiply it out later, it becomes negative again. What goes in parentheses? Well, whatever's left over. For my first term, it's 2 times 2, which is 4, times t, so 4t squared for my first term. Okay? Now I'm looking up at my equation. I had a plus here, but I factored out a negative, and when I factor out a negative, it changes the sign of everything in the parentheses. It changed the sign of this first thing to positive. It's going to change the sign of this one to negative. And I'm going to show that by making it a minus sign. So this is going to be minus whatever I have left here. 15, 3 times 5 is 15. That's going to be 15t. And then my last term here, I don't have anything left. I got rid of both things. So what happens when I factor out everything? What am I going to put in my parentheses? Well, then we just put the number 1. And in this case, it's going to be a minus 1 because that negative changes this last term here, changes the sign, so it becomes a minus instead of a plus. But that's a key thing. If you end up factoring out everything, then it's just going to become 1. And let's just double check to make sure this distributes back in to make this. Negative 4 times 4t squared is negative 16t squared. Negative 4 times negative 15t is going to be plus 60t. And then negative 4 times negative 1 is plus 4. That is how you do factorization using the greatest common factor. Go ahead and work numbers 1 through 30, focusing on this important new technique.